The work I did in my PhD about nitrogen management in respect to canola was really aimed at identifying how the benefit to crop yield came with the use of nitrogen in that particular crop. The work that was done on these grey soils in the Wimmera identified that nitrogen application changed the canopy of the canola crop so that the canola shaded the ground and so actually stopped the amount of soil evaporation, that water was then preserved for use in transpiration in the crop, so that the water use efficiency improved by nitrogen, mainly because of the reserving of water from early loss through soil evaporation to later loss through transpiration, which is productive. The problem with that work that we did then was that the strategy in those times for nitrogen was to have nitrogen all placed at seeding. At that time, nitrogen fertilisers weren't that commonly used, and when I say that time, I'm talking about the late 80s to mid 90s. The strategy was the same as phosphorus. That is, you put nitrogen in at sowing and you waited to see what happened with the season. Two developments occurred then. Firstly, we mentioned about the water use efficiency. French and Schultz did some wonderful work quantifying what water use efficiency meant to growers in terms of setting yield potentials. And the modelling, the crop simulation modelling fraternity came on board and used their crop simulation models to estimate what yield potentials would be. So immediately we could have an estimate reasonably early in the season of what a water limited yield potential was. And the work we did was then trying to identify how much nitrogen you would need to meet that water limited potential. Doesn't mean you put all the nitrogen in at seeding, because you know the least about the season at that time. Climate forecasting was just coming in, and that was helping identify some of those things. So the combination of crop simulation modelling and climate forecasting really started to help growers identify yield potentials. And then in terms of a nutrition sense, we did quite a bit of work here and in the Western District looking at how you would manage nitrogen best to meet that yield potential. And what that meant in a practical sense was actually applying nitrogen maybe to 1/3 of your yield potential early on, so to get the crop through to growth stage 30, the start of stem elongation, and then feed the crop as the yield potential unrolled. And that sounds simple now, but in those times it was sort of, people didn't understand that you would you remove some of your risk by deferring the nitrogen application to the later season. They were concerned that you would lose yield potential by not having all your nutrition at the start. That, in more recent years in high rainfall zones, such as in the Western District, where cropping has become a lot more common, and yield potentials are quite a lot higher than in some of the Wimmera and Mallee, for example, the management actually can extend to 2 or 3 applications. And again, what we were looking at, say with some work, some research we did with timing of nitrogen in terms of trying to promote protein, was that you could apply nitrogen up to almost when the crop was flowering and still get a protein benefit, so still increase grain protein. There's a lot of luck involved in that in terms of what happens in the rest of the, in that season after anthesis, but that potential was there. And in some years there's been big protein bonuses for grain, in other years not so big, but it's certainly in a year like the recent 2016 with a really mild spring and good winter rains, the potential's been there to push protein, but again, certainly requires a little bit of luck. The soils are still productive if managed properly, if weed control, nutrition and diseases are all addressed, and the other parts of the agronomic packages are put together.